This is a hypothesis test about the population proportion P, and we are going to use the p-value method to do the hypothesis test. People in the age group 40 to 59 years old constitute 32% of the population of people who go to the movies. A theater complex randomly selected and surveyed 423 of their customers and found that 170 of them were in this age group 40 to 59 years old. At an alpha of 0.01, test whether this theater complex differs from the stated proportion of 32%. So let's put down our hypothesis. The equal sign always goes with the null hypothesis, and we are hypothesizing that the proportion is 32%. Then the alternative would be the differs from means not equal to, and that appears to be the claim. I'm getting that from this sentence right here. Differs from means not equal to, and we're wondering whether this complex differs from that, the stated proportion of 32%. We're going to calculate a test value, and the formula. We're going to take p hat and subtract the hypothesized proportion, and then in the denominator we'll have the hypothesized proportion times its complement over the sample size. So the p hat is formed by looking at these numbers. Out of the 423 customers, 170 of them were in this age group, and so 170 over 423 is going to be the sample proportion. The p hat is the sample proportion. This is not a very nice decimal, so I'm not going to use the decimal. I'm not going to round it. I'm just going to use the fraction as it is. Still using a decimal for the hypothesized p. If 32% of the moviegoers are in this age, then 68% would not be in that age group, and the sample size is 423. And when you put this in your calculator, you'll get close to 3.61 for your test value. As you type that in your calculator, you can type this just the way it looks, 170 divided by 423 minus 0.32. Make sure you put parentheses around it before you hit this division sign. Then your p-value, you're going to have to go to your table, and you're going to look up 3.61. Now, when you do that, your table doesn't have that big of numbers on it. And so it says for z values that are greater than 3.49, you'll use 0.9999. So you'll have to do that on this problem. And that's this area to the left. And so the area that you're looking for to the right is 0, 0, 0, 1, like that. And so this is a two-tailed test. So you have to double this area that's on the right. That's your p-value. To make your decision, you compare your p-value to your alpha. So we'll compare this p-value to the alpha. And the alpha was 0.1. When the p-value is smaller than the alpha, it's a lot smaller than the alpha, you reject the null because the p-value less than the alpha. We're rejecting the null hypothesis. Now let's go back and look at what our hypotheses were. We're actually rejecting this null hypothesis, which means we're saying the alternative is true, and the alternative has the claim attached to it. So we're actually supporting the claim. And then one more time, we're rejecting the null, which means the alternative is true. And since the claim is attached to the alternative, we're supporting that. So we're saying there's enough evidence to support the claim that at this theater complex, the proportion of adults in the age group 40 to 59 is not equal to 32%.